We're going to quickly look at conditional probability. Well, the probability of an event may be different if you know that a dependent event has already occurred. So, for instance, asking for the probability that you'll pick an ace from a pack of cards is quite different from asking, given that the card is a diamond, what then is the probability that the card is an ace. So basically, we know something extra. Now we can view it like this. In other words, event A has already occurred because we're saying given that the card is a diamond, so we know that's occurred, and we're saying that given that that has occurred, what is the chance that it's going to be an ace. So we'll fill the Venn diagram in just the same way. So A is the chance, or all the outcomes where we draw a diamond, and B are all the outcomes where we draw an ace. And as before, we fill in the intersection first. So this is A and B, so that the card is a diamond and an ace. And of course there's only one event there. So we can now look at this space here. How many outcomes are there where the card is a diamond? Well, 13 altogether, so that this the number of outcomes in this closed curve is 13, we must make this 12. And B are the outcomes that the card drawn is an ace, and so there would be 4 altogether in this closed curve, but we've got 1 in this intersection, so that leaves 3 here. So having got 16 altogether within the closed curves, we then need the balance here. So this is going to be 36 cards to make up the 52 that we could have altogether. The way to look at it is this. The card being a diamond, that has already occurred. So the sample space is now restricted to just this closed curve, because that's happened. And what we're asking is, given that this has happened, what is the probability that the card is an ace? And we can see here, this intersection here represents the events of it being an ace. So we've got a 1 chance out of 13. So the way to look at conditional probability is that it reduces or restricts or narrows, however you want to look at it, the sample space down. So instead of being out of 52 cards, the fact that we know it's a diamond has restricted it now down to 13. And then we look at the outcome B, out of that 13, how many outcomes are there, and it's 1 out of 13. We can look at this more formally using the formula, which really you need to memorize. We use this notation: the probability of B given that A has occurred, so we use this vertical line, so this is the probability of B given that A has already occurred, is equal to the intersection of B and A divided by the probability of A. So the probability of B intersection A, now what I'll do is I'll just highlight this so we're clear. B intersection A is this part of the Venn diagram. So this probability is 1 out of 52. And the probability of A is this area. So this is 13 out of 52. And then if 152 divided by 1352 is equal to 1 over 13. Whoops. Which is just what we found, just visualizing what was going on in the Venn diagram. But this is a more formal way using probabilities.